Hey everyone, welcome to my video on using the trapezoid or Simpsons rule. And in this one I want to focus on just the calculation part of it. So you've probably already seen videos on where these formulas come from. Trapezoid, just to remind, you get 1/2 our delta x, and then this string of function values, f of x0, that's your starting, and then 2 times all of these other ones, f of x1, x2, x3, all the way down to you get to the next to last one, and then just a single f of xn, which is usually this b right here. So you're going x1, x2, all the way down to xn. Simpsons looks very similar, but it has a 1/3 times that delta x, and you still start with f of x0, but now instead of all 2's, you get this alternating 4, 2, 4, 2, 4, 2, until you get to the next to last one, which should end with a 4, and then finally that last f of x bin again. And it is important to note, Simpsons rule you can only use when n is even. So hopefully you've already seen the videos on where these come from. I'm not gonna really spend time on that. Mostly I want to focus on what is the easiest way to calculate these out using the calculator or Desmos. So I have this problem right here. Find T6 or S sub 6 for f of x is x plus sine x on the interval 0 to 3. And we'll just go ahead and calculate both of these out. And the idea that I want to look at is how can I do that without having to write down a ton of numbers, plug in a bunch of stuff, and just have it be a lot of work entering those in. So I'm going to start with the calculator, and then we'll look at Desmos as well. So the first thing, if you're using the calculator, is, well, actually, I should go back. The very first thing is I want to compute this delta x. So I'm just going to go ahead and do that real quick. So our delta x on this one is going to be our b minus a, remember, so 3 minus 0 over n, which in this case is 6. So for us that's 1/2 or 0.5. So that will be our delta x for both of these computations. All right. So now that I got that, what I'm going to do on the calculator is go ahead and put these in. So we already got x plus sine x right there. I'm going to clear this one out. And you do want to make sure you're in radian mode whenever you're dealing with trig functions. So always just a good idea to look at that. So now we got y equals x plus sine x in here. Now there's a couple ways you can do it. One is a little more looking by hand, which is to use the table. So if I want to go to say second table, this gives me a table of values, and I can hit second window, the table set, and it will give me an option of where I want to start and the change I want in my table. So this is sort of like your delta x. So change in table, we want to be 0.5. We do want to start at 0, and then we'll just say second table again, and it'll give us that 0, 0.5, 1, 1.5 all the way down, and the function value. So one thing you can do is you can just write these down from 0 to 3. So there's not a lot of them, just 6 of them, or actually 7. So write those down and use them later, and just put those in the formula, whatever values you wrote down. That requires a little more typing than I like, a little more writing a whole bunch of these down. So it is one option, but I would rather do something a little different. So what I'm going to do is I'm going to take this 1/2 times my delta x 0.5, and right now I'm doing the trapezoid rule, and then we'll put in our parentheses. So, or if you want to put times and then parentheses. Our first one is that f of x0, so that was at 0. And what I'm going to do is use the variables button right there and scroll over to y variable, so arrow over and then hit function and then y1. And right next to that, I'm going to put in parentheses my first value. So we're starting at 0. So this will take 0, plug it into y1, give me a value right there. Plus 2 times, and then I'm going to just continue on for the rest of these. So you wouldn't really want to do this for, if you had, say, n is 30, but for things like 6 or 8, maybe 10's getting a little much, but 6 or 8, this is usually a pretty good method to go with. And I'm just going to repeat that for all the values. So until we get to 3, stepping up by 1/2 each time. So again, do variables, y variables, function y1, and this time I'm going to put in my next value, 0.5. All right, keep going with that. So I'll go ahead and type a bunch of these in, and from there we'll go ahead and evaluate. Alright, so if I go ahead and evaluate that, what we're going to get is the 6.44836 number that's right there. So that would be my estimate of this integral from 0 to 3 using the trapezoid rule with only 6 approximations. N is 6. The nice thing, if you're doing a couple of these with some similar things, so if I want to do Simpsons rule of 6, I don't have to retype all of that. I can just hit second enter, and it will give me everything that I just typed, and now I can just go and change those particular values that I want. So we have a 1/3 in front, and a lot of the rest of this is the same except for a couple of these coefficients. So I'm starting with, on that y1, a 4, then a 2, then a 4, then a 2, and then a 4 again, and then the last one is just how it is. So we'll just hit enter, and that gives me about 6.4907. So we can go ahead and put those down as our values for trapezoid and Simpsons on those guys. Alright, so here are my values. Trapezoid about 6.448, Simpsons 6.491. Let's go ahead and try it with Desmos. I'm just going to use the same function just so you can see how it would go on there. And a couple things I want to point out. One is if you have this kind of list format, Desmos will give you a list. So A is 0, and then 0.5, 1, 2, all the way down. So that'll give me this 13 element list. So that's kind of how that looks. If I put my function, so there's my x plus sine of x. Notice I put this f of x in front right there. And now what you can do is you can do things like plot a f of a. So this would give me all those dots along the way. Because our coefficients are going to vary, we're basically going to have to do what we did on the calculator, which is just type stuff in. So you don't really have to include this piece right here if you don't want to. I just did that to show you how you can create a series of dots and how you can use that a and f of a in some calculations. So what we're going to do here is basically just type in what we had before. So I'm going to do the 1/2 times delta x, which was 0.5, and then times, and then now I'm going to put in all of those f of, and then input your values. So f of 0, and again I have to 2 times f of 0.5, so I just have to go in and put all these values in for these guys. If you want, you can put in like A1 and it'll do it that way. It's a little more typing than just following it down, so you don't really have to unless you're going to do a bunch and you want to change this list of A in this function. You can do it more generically, but I'm just going to type it in like this for now. So we got 2 as a coefficient for all these. So you can see on this one that we get the same as we got on the calculator, that 6.448 number. Again, I can just change these, or if you want to, I just copy and paste. I can change this to a 4 if I want Simpsons rule, 4, 2, 4, 2, 4, and put those in that way. And this gives me, since I didn't put the 1/3 in front, a little bit different value. So now that we got the 1/3, there's our 6.491 approximately. So that's kind of the idea. Again, if I had, say, 30 of these, I would probably want a spreadsheet or something that I could put in all of these A's that are going from 0 to some number. In our case, it's just going to 3 on these guys. 0 to 3 every 0.5 down one column, the function values down another column, and then coefficients in another column, and manipulate them that way using the spreadsheet tools. So if you get more than about 6 or 8, probably Excel or some other spreadsheet is going to be better. But normally on exams or things like that, about 4, 6, maybe 8 is the limit on a lot of these for evaluating Simpsons rule or trapezoid rule. So anyway, that's how you'd use the calculator or Desmos, at least a couple ways. So hope that helps.